Hello, welcome back to another Java tutorial. In this tutorial, we'll be learning about how the Gamepad class works and how to use that for our code, as well as something called an enumerator and the switch. So let's begin. To start with, you can see that I've already started a bit of the Gamepad testing code. To make this class, what you'll need to do is right-click on org.firstinspires, blah, 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 new Java class, and then type all of this. It might look like a lot, but it's really, if I would have included this in the tutorial, it would have just padded the runtime. All of these import statements are pretty simple and self-explanatory. We just need these packages. So import all of these. And then up here, this will be in by default. It's just saying that the code is inside the package. Then at teleop, that's declaring that it's a teleop class. Then extends linear op mode. That means that it will work with the linear op mode class. And then at override public void run op mode. Perfect, right? Seems great. So now what we need to do is add in public gamepad testing. We shouldn't use this. We shouldn't need this, but just in case. I just muted myself. Oops. So it should be good now. We don't need that semicolon. And then inside of run op mode, we can go ahead and do wait for start. That will mean that all of the code before it, everything up here will run until when you press initialize. Then once you press the start button, it'll move on. Then we can go while op mode is active. And then whatever we want in there. That is our main teleop loop. So now we can begin for realsies. So to start with, we will declare a couple gamepad objects. So gamepad current gamepad 1 equals new gamepad. Great. Then we'll go gamepad previous gamepad 1 equals new gamepad. We'll only be working with gamepad 1 today. Don't worry about gamepad 2 yet. So the reason we're doing current and previous, that'll become obvious in a bit, but for the start, we're just going to work with current gamepad. So if you don't want to put previous in yet, that's totally fine. So now we'll go down, and inside of run op mode, we're going to do current gamepad 1 dot copy gamepad 1. Gamepad 1 is a built-in function, which is built into linear op mode. Sorry, not function, method. It's a built-in method to linear op mode, and it is just whichever gamepad you plug in and press start A. And it has all the buttons inside it, whatever. So that's great, but we want something else. We want to create our own, because that way it'll just be a little faster. But there's an error here, and I'll tell you why. Because the code doesn't want you to run it if it's not sure that it won't cause an error. And this might cause an error. Say gamepad 1 wasn't initialized correctly, which there's no reason it shouldn't be. But the code doesn't know that. The code doesn't know that it will always be okay. So what the code wants us to do is try. Not that. We don't want that far. So now in here, there we go. And then we want catch. And then what we're going to catch is robot core exception E. We're just naming whatever the exception is, and then close brackets. So this, you can use this type of statement if you know that something might cause an error. And that way, if it does cause an error, it won't completely break the code. You can just do whatever it says in here. But this will never happen, so we don't need it to do anything special, because this will never error on us. So now that we've done that, we can go ahead and wait for start. Then, while op mode is active, we're going to go ahead and do this exact same thing again, because every op mode loop, we want current gamepad 1 to recopy gamepad 1. Perfect. So next, we are going to start by doing some basic robot motion stuff. But to start with, we're not even going to work with the robot at all today, because you would need to create a fully working robot in all other respects for you to understand what all these buttons really do. So instead, we're just going to work with telemetry, okay? So at the end of this, at the end of the, oh, that's not the while op mode is active loop. Now I'm inside the while op mode is active loop. I'm going to go telemetry dot update. So at the end of that, it'll just update the telemetry. Perfect. So then what we're going to do is we're going to make a couple new variables. So double x move, y move, and let's make those capital. X move, y move, z move. So I don't know if you've been in physics, but X and Y are pretty self-explanatory. It's just the XY plane. It's horizontal on the ground. Z is actually vertical. The robot can't move upwards, obviously, but we're calling it Z move because that upward, what's the word? Sorry. Vector, that upward vector can signify the rotation of the robot. So I'm calling it Z move. You could call it R move. R move would probably be better. Actually, screw it. I'll stick to R move. There we go. I've always called it Z move, but I'm changing for you guys. So R move. Anyway, let's move back down. So we can go ahead, and after we've done this, we can go X move equals current gamepad 1. Oh, what did we not do? Of course, X capital M move equals current gamepad 1 dot left underscore stick underscore X. So the left stick X is the horizontal movement of the left stick. So X move, horizontal, side to side. We want to know how far we've moved the left stick horizontal, side to side. Perfect. Now Y move will be very similar. Current gamepad 1 dot left stick Y. But there's an interesting quirk with the Y-axis of the sticks. For whatever reason, don't ask me, these thumbsticks have it so that tilting it forward is negative and towards you backward is positive. So we're going to set that to negative. So if you tilt it forward, Y move will be positive. Backward, Y move will be negative. Perfect. It's good now. Then we're going to go R move equals current gamepad 1 dot right stick X. There we go. So now the left stick will control forward and side to side movement. The right stick will just control side to side rotation. So now we have these variables. Perfect. There's a lot of stuff that we can do with them during the actual robot motion, but we're not worrying about robot motion right now. We're just worrying about these pure values. But how do you read these pure values? That's right. That's right. Oh, you're so smart. Telemetry. So what we got to do, telemetry.add data, and then we're going to say the name first. So we're going to call this xmove, and then there's the data, xmove, and we're going to repeat this process for all of the different, oh, don't want to do that, ymove. And finally, rmove. So now, if you run the code now, unless I made an egregious error in this code, which maybe, you'll see. Text me if I did. If I made an egregious error in this code, then that means that it won't do anything. But if I didn't, which I shouldn't have, then what'll happen is you'll plug in your gamepad, press Start A, and then if you tilt up on the left stick, it'll say Y move is positive, and then it'll do the same for all the others, which is perfect. Great. Awesome. So that's all well and good, but there's a lot of other stuff we want to do besides just sticks. So we're going to start talking about buttons. So to start with, I'm going to make a new variable, Boolean. I love that word, Boolean. Say that out loud a couple times. If you're in class, whatever, Boolean, Boolean, Boolean. So Boolean light on, and then down here, we're going to say, and this is a hypothetical light, then down here, after the actual movement variable assignments, we're going to go ahead and light on equals current gamepad1.a. So that means that whenever you're, what's the error? I don't know what it's telling me. Whatever. The error is gone. Sometimes it'll take a while. Anyway, light on equals current gamepad 1.a. That means that whenever you're pressing the A button, the light will be on. So over here, we'll put on telemetry.add line. Sorry. To start with, we'll do telemetry.add line and then just an empty thing. That'll just add an empty line, which means that it'll be a nice, easy break so we can see number one, a chunk of these values, and then after that, we'll see a chunk of the other values. So this one will just be light and then light on. So that'll just say either true or false, whether or not the light is on or not. So then what we can do is we can talk about the triggers. So the triggers are the bottom ones. So if you have PS4, if you have PlayStation, that'll be L2 and R2. If you have Switch, that'll be ZLZR. And then if you have Xbox, that would be RT and LT. But on here, they're called left and right triggers. So unlike all the buttons, which the buttons are gamepad A, gamepad 1.b, D-pad left, the bumpers, which are right above them, even the sticks if you press them in. But the triggers are analog, similarly to the left and right sticks. So what we can do is we can go ahead and actually I gotta make another variable. Wheel speed, we'll call this wheel speed, and imagine if you will a hypothetical wheel on the top of the robot that turns with a speed that is dependent on the trigger that you press. That's such a fantastical scenario. I don't see how that would ever come about. It did in Freight Frenzy. That was very important, actually. Generally, you didn't need to control the speed on the fly, but for the sake of this tutorial, we will. So we're going to set wheel speed equals current gamepad 1 dot right trigger. So this is a time when I think I can tell you about dead zones. So number one, we'll just do this. Dead zones are the area of the motion of the area of the motion of some analog input, so either the stick or the trigger, where it will not output anything. That means that if you press it in a little bit, it won't output anything. And that's because there's always some element of error. So if you don't have dead zones, then it will output like a tiny little value at all times, and that would be bad. So generally the dead zone is about 0.2. So it will never, when you press the trigger in it will never give you a value less than 0.2. As soon you press in, and then as soon as you get to 0.2, it'll start giving you a value of 0.2. Then you press it in more, and it'll keep going higher. So what this does is it will set that wheel speed from 0.2 to 1. Perfect. Say we wanted the wheel speed to be negative, we could just put a negative right there. And that's the reason why it's so important that we set these variables at the start. Because you might be tempted to think, oh, we might as well, if it's just the right trigger, we might as well just use the right trigger value. You might even be tempted to use gamepad 1.right trigger instead of doing current gamepad. But these layers of abstraction help you to understand what your code does. You can't have too many layers of abstraction, obviously. Oh, I do not know what I just did. I don't know if you even saw that. Oops. Anyway, these layers of abstraction, you don't want too many, but if you have just the right amount, it really makes your code easy to understand for you when you're going back down the line and everybody else who reads it. I confess that my code maybe isn't the easiest to understand, but I think it's been easier than it has in previous years. So that's why this is important. Also because when you are using the robot, when you're practicing, you might realize that some other input method might be better. And that happens a lot. It's great. You should never just stick to what you started with. You should always try to improve. So you might realize, oh, I don't like using the right trigger. I like using the left trigger. So instead of having to go through your code and change every current gamepad 1.right trigger, all you have to do is go right to wheel speed and change this to left trigger. And then every other time you've used wheel speed, you won't have to change anything. That's the same for That's the same for up here. Say you made a mistake and you wanted it to be positive instead. There's a bunch of other examples, and we'll get into better examples next time. But that'll be it for today. That's the basics of Gamepad. You've learned analog inputs, you've learned digital inputs, digital meaning either 0 or 1, on or off. There'll be some more advanced methods of taking the input next time. But you've learned basically all you need to know about the actual basic gamepad methods for now. So, with that said, see you next time, and good luck with your code.